In this video, we are going to provide solutions to one of the practical problems in differential equations. The problem that we are looking at is the one where water is leaking out of a water tank with vertical sides of side H, and basically we are interested to find out how the depth of water in the tank is changing with respect to time. So in the very first part, what we need to show is that dx dt is equals to negative kx. My x is the depth of water in the tank at time t, and in this case we have such a differential equation where k is a positive constant. The plan, as we have given in the hints earlier, was that dv dt is equals to negative ax. We need to show that dx dt is equals to negative kx. So the plan was to express v in terms of x and then to introduce a new positive constant. So the solution goes as such. I have dv dt is equals to negative ax, but v is equals to base area times height, where in this case my b or my base area is represented by b. In particular, the base area is fixed. So now dv dt is equals to d dt of bx, but because b is a constant, this is equals to b d dt of x, which, because dv dt is equals to negative ax, I have b dx dt equals to negative ax. So this implies that dx dt is equals to negative a over bx, which I can then write this as negative kx, where k is a positive constant. Reason, because a is positive and the base area of a water tank has to be positive. So shown. So that's for part 1. In part 2, we are supposed to determine the depth of water when t is equals to half. So the plan was to basically solve the differential equation. To do so, the hints were that we can separate the variables and then we integrate on both sides of the equation with respect to t, make use of the given information to find the constants of integration, and then eventually find the value of x when t is equals to 0.5. So the solution would be, we start off with dx dt equals to negative kx. We separate the variables, so we bring all the x to one side. I end up with 1 over x dx dt is equals to negative k. Then I integrate both sides of the equation with respect to time. And what that gives me is integrate 1 over x with respect to x is equals to integrate negative k with respect to time. So this gives me ln x is equals to negative kt plus c. And the reason why we don't have mod x is because x is always positive, since it is the depth of water in the tank. Now I take exponential on both sides. I get x is equals to e to the power negative kt plus c, which I can write as e to the power c times e to the power negative kt, and to simplify matters I write e to the power c as the constant a. Now the objective is to solve for the two arbitrary constants in this solution of x. In fact, what we have found is the general solution. But the question gives us two pieces of information so that I can find the constants. First of all, I know that when t is 0, the height of water in the tank is the height of the tank, so x is equals to h. So this will tell me that e to the power 0 is equals to h. This implies that a is equals to h. So what we have is x is then equals to h e to the power negative kt. Similarly, when t is equals to 2, we are given that x is equals to h over 2. So if we will sub this into the equation, we will get h over 2 is equals to h e to the power of negative 2k. And if we were to solve this equation, we will find that k is equals to half ln 2. So this is the arbitrary constant we found, and we also found that a is equals to h. So having found the two arbitrary constants, I can now write down the particular solution. Therefore x is equals to h e to the power of negative half ln 2 multiplied by t. The last part of this question requires me to find the value of x when t is equals to half. So when t is equals to half, we have x is equals to h e to the power of negative half ln 2 whole thing multiplied by half. And if we were to simplify this, we will end up having h times 2 to the power of negative 1/4. Or if you prefer to give it in 3 significant figures, that would be 0.841h to 3sf. So this is the solutions for part 2, and part 2 in particular is a typical differential equations question where first of all we need to formulate the differential equation, solve for the general solution, given extra information, find the particular solution, and eventually, in particular in this case, find the value of x when t is equals to half.